The thing is, nowadays, most cars come with turbos. Things have moved on considerably. This video is going to bring us up to date and look at areas that we need to be aware of when driving a turbocharged car. And I'm also going to look at the likelihood of this problem on a modern engine. But in this video, we're going to look at 8 areas that people often fall down on when it comes to prolonging the life of a turbo. There's things that we can do inadvertently that damage our turbocharged engine. One of the comments from one of our viewers, back in the 80s, he bought an MG Metro Turbo. If you don't know, look it up. They're good fun cars, tiny, probably rusted away now, but they were good fun. They had a decent amount of power and you could really enjoy them. So the instructions said that you should leave the car idling for 15 seconds before you drive it, and you should let it idle for 15 seconds after you've driven it to allow the turbo and the oil and everything in the car to warm up or cool down appropriately. And the manual actually said if you don't do that, you'll damage the turbocharger. Does this advice apply to modern cars? Well, we've discussed cold starts and cold start problems, and there's certainly an element of additional wear and tear that goes on in a cold engine, and the oil needs to get up to grade. The turbocharger has fairly fast spinning components inside it, so oil delivery and oil viscosity is critical. So you don't really want to be pushing the turbo too hard in those first 15 to 30 seconds, and certainly after a spirited run. But synthetic oils have come a long way. They can protect engines even when they're cold. Manufacturers have also moved on, so your coolant circuit and in some cases the oil flow will also continue after you shut the engine off. So in these modern engines, a lot of protection has gone in to mitigate the problem on those early turbos where they needed time to warm up and they also needed time to cool down, and again for the oil to be circulated through this spinning turbo that is slowing up. So it's certainly sensible to let the engine idle for 15 to 30 seconds just to let the oil pressure get up and for things in the engine to start to warm up. Whether you drive ridiculously carefully for the first 15 or 20 minutes is up to you. If you want your car to last a long time, you'll be avoiding the high RPM and the red line driving until at least the oil has got up to operating temperature. So that might take 10 to 15 minutes. But generally, just go careful when you've just started your engine. Be careful, don't be paranoid. Modern engines have gone a long way to mitigate the problems associated with those older turbos, but just by being careful, you can prolong the life of your turbocharger. General maintenance, if you have a turbo engine, it really is vital to keep the air filter clean. It's sucking in a lot more air, so that filter is going to get dirty very quickly. Manufacturers have generally fitted larger filters on their turbocharged engines, so they need changing less often. They still offer a decent amount of filtration. Symptoms to look out for in your turbocharger are whining noises, squeaking noises, siren noises, a whooshing of air. If that's happening anywhere in the engine bay, suspect there is a split pipe. It's often around the joins. Now, as a driver, think about your throttle control. Try and be progressive with the throttle control. It's not a binary pedal. It's not on or off, as a lot of drivers seem to think. With a turbocharged engine, having that progressive control on the throttle gives the turbo a little bit of a chance to spool up, to accelerate, to decelerate. The blow-off valves, the diverter valves, the wastegate, they're working steadily. You're not snapping open and snapping closed. The sudden changes in pressure that you get with aggressive throttle controls can shorten the life of these components. By how much? Well, probably not loads. They're quite solidly built. Some manufacturers have put a lot of plastic in modern parts, so they're more prone to fail. But as a driver, you want to prolong the life of the turbocharger as long as possible. And just adjusting that driving style so we're not brutal, we're not on and off on the accelerator, can go a long way to mitigating potential problems that might crop up if we are not quite so careful and progressive on that throttle control. So another area is servicing. Don't view servicing as an unnecessary expense, and if the manufacturer says 9,000 miles, you try and push it to 12,000 in order to save a little bit of money. You're not saving money doing that. You're accelerating the wear and tear on your engine. The engine oil does degrade over time. It collects all sorts of debris and other fluids. The viscosity of the oil changes over time. It's also picking up metal particles particles. Now, a lot of the metal particles are caught inside the oil filter, but the small, tiny metal particles are still having an abrasive effect inside the engine. And if it gets into the turbocharger, it's going to accelerate the wear and tear on the turbo itself. So really don't skimp on your servicing. Make sure you use a good quality oil as recommended by the manufacturer, and it's all carefully formulated and designed to protect your engine. There are many people out there with cars that have done ridiculous mileages, and when you talk to them, they've all shortened the service interval to get those ridiculous Starship mileages. Another driving thing that we need to look at is low speed pre-ignition. This happens when you're lugging, so you're driving at very low RPM. By low, I mean near tick over. A lot of hypermilers do this thinking they're getting more fuel economy from the engine. I've discussed that to death in other videos, so check them out if you're interested in the merits of hypermiling but want to avoid the problems associated with lugging an engine. Low speed pre-ignition is often caused by the vapors building up inside the engine, the oils and everything else. It's a high compression engine. If that ignites prematurely at these low speeds, it can cause all sorts of problems and difficulties inside the engine, reducing the overall lifespan of the engine. Again, it's not going to kill the engine and blow it up necessarily, but in the main, you're just reducing the overall life of the engine. So please don't lug your turbocharged engine. We've got to talk about fuel quality as well. We're not just talking about octane, although that is an important factor. The fuel supplied at most filling stations now has an ethanol component within it. So if you buy E10, for example, that's telling you that 10% of that fuel has ethanol in it. If you have E5, 5% of that fuel is ethanol. Ethanol itself, it's not great on older engines. It can damage rubber seals and components within the engine itself. If your engine has not been designed to use ethanol fuels, you're restricted to using E5, which is a higher octane fuel. But most turbocharged engines run at higher compression. They require more protection against knock, and higher octane fuel provides that. It's less likely to have knock and detonation. The octane of the fuel resists knock. So if you're using a low octane fuel in a high compression turbocharged engine that was designed for higher octane fuel, you're not only just going to be down on power, you're risking damage to your engine. If your engine is knocking excessively, it's going to do its best to protect itself. All the systems inside are going to detect knock and back off. But having that knock going on inside the engine is potentially causing damage to the metals inside the engine. It's causing pitting and other damage to the pistons. Please choose the fuel that is recommended for your engine. Check as well the blow-off valve on the turbocharger. So this diverts the excess pressure that builds up in a turbo when you lift off, and in most cases it diverts it back to the intake. There are atmospheric dump valves as well that vent this out to the atmosphere. Some engines don't like that setup, but do your research please if you're thinking of upgrading or converting to an atmospheric dump valve. And also all of the pipes and hoses around the intercooler, if they split, you're going to be down on power. The turbocharger is going to be working too hard to supply the air that the car is expecting. So you can effectively, in some cases, overdrive a turbocharger because you've got an air leak, and you won't notice it because the car's doing a good job at compensating for that lack of air by spooling up the turbo even faster. So don't ignore these splits and these problems that you get. So you might also notice excessive smoke coming from the engine. So again, the engine's going to go a long way to run as smoothly as it can. It may be dumping more air, more fuel in. It might be adjusting or doing its best to adjust to avoid the problem. But don't ignore these problems. If you've got an engine check light on, get your diagnostic tool out, download the error codes and work out where the problem is, because these problems often escalate and get worse. Especially on a turbocharged engine, everything's working at higher pressures, higher tolerances. It's more critical that your components in a turbocharged engine are working effectively than on maybe a large capacity naturally aspirated engine. If you've noticed that your car is down on power, again, that's a clue there's potentially a problem there that you need to address. So noticing that early symptom can avoid the more expensive problems that crop up later. So mitigating problems, what have manufacturers done? Well, the engine is much more complex now. There's a lot more management. We're now dealing with a drive-by-wire setup where the computer is making adjustments to the throttle rather than it being directly controlled by a cable connected to the accelerator pedal. In a modern car, it's going to protect itself. If the engine is cold, if the oil hasn't circulated properly, it's going to limit the throttle movement. So being an idiot driver is not as much of a problem as it used to be. Some cars also restrict the amount of RPM that you can use when the engine is cold, and it's going to do everything it can to warm up the engine as quickly as possible. So that may mean restricting the flow of coolant around the radiator. It may mean slowing up or speeding up the flow of oil around the engine, changing the oil pressure. There's a lot of things that the modern engine can do to protect itself. And when it comes to stop-start engines and the engine suddenly being switched off, we don't have to worry as much now about the oil in the turbo and the turbo getting lubrication while it spools down, because with electronic oil pumps and electric water cooling systems, the pump is still driving the flow of oil to the turbocharger. So your modern turbocharged engine has come a long way. A lot of the things that we used to really need to be careful about on older turbocharged engines are just sensible precautions we can take on a modern turbocharged engine to prevent problems, to extend the life of our turbocharged engine. So we all want to avoid breakdowns, and we all want our car to last as long as possible. Adjusting our driving habits and keeping on top of these maintenance items can really extend the lifespan of our turbocharged engine. So thanks for watching. Please boot the like button. That really does help us to get out there. Please subscribe to the channel if you haven't done so already. It really does help when the algorithm sees people subscribing to the channel. And I've lined this video and this playlist up for you that you should find really interesting. Thanks for watching. See you in this next video.